Hello everyone, today we are exploring a critical but often invisible bridge between biology and global commerce, the dispersal of marine invertebrate larvae. Most of us recognize adult form of marine life like barnacles, mussels or crabs, but their journey begins in the early planktonic stages known as larvae. These larvae are distinct from their adult forms and undergo metamorphosis, a total transformations into a juvenile or adult form that often involves a habitat shift. This process is vital for the survival of marine species as it allows for genetic mixing, population connectivity, and the colonization of new environment. However, in our modern world, this natural dispersal is being hijacked by global shipping, leading to significant environmental challenges. Before we look at ships, we must understand how these larvae choose their homes. Larvae rely on specific environmental cues to settle, such as biofilms, conspecific chemicals, light, and even tides. For species like oysters, sea urchins, and lobsters, finding the right substrate is a matter of life or death. In a natural setting, this ensures species reach healthy reefs or rocky shores. But in an industrial setting, these larvae encounter two primary man-made factors like ballast water and biofouling. Ballast water is seawater pumped into ship's hull to maintain stability and trim. During this process, the ship unintentionally entrains larvae, eggs, and even small fish, only to release them thousands of miles away at a destination port. This has introduced notorious invasive species like the comb jelly, Maaf lidi, the green crab, Carnicus minas, and toxic dinoflagellate into new ecosystem. There is biofouling, which is the accumulation of microbes and microfoulers on submerged surface, essentially the outside of the ship. It starts with a simple conditioning film, which leads to a microbiofilm, and eventually microfoulers like barnacles and mussels settle and mature. This isn't just a biological curiosity, it's an economic and environmental crisis for the shipping industry. Biofouling leads to higher drag and increased fuel use. For the environment, it acts as a consistent translocation vector for moving invasive species into new territories and damaging local aquaculture and infrastructure. Impacts are far-reaching, resulting in native species displacement, habitat modifications, and massive management costs. We are currently facing a perfect storm of challenges. First, climate change is fundamentally altering larval dispersion. Ocean warming causes faster larval development but leads to higher stress and mortality. Meanwhile, ocean acidification impairs the ability of shell-forming larvae to undergo calcification and metamorphosis. Second, the global shipping industry is expanding. More voyages and new routes create higher propagate pressure, meaning more invasive organisms are being introduced more often. combat this, we have international regulations like the IMO Ballast Water Management Convention and the IMO Biofouling Guidelines, which require treatment, exchange, and port inspection. While these strategies are effective at reducing many organisms, we still face gaps in compliance and enforcement. Current strategies like modern ballast treatment and specialized coatings do work. However, they struggle with variable efficacy against very small stages or microbes. There are also significant costs associated with maintenance and niche areas on ships that are hard to clean. So, what is the path forward? The future lies in multi-stage treatment technologies, such as combining UV, advanced oxidation, and real-time viability sensors. We are also looking toward biomimetic coatings and low-toxicity biocides that prevent larvae from settling without poisoning the waters. Operationally, we need stricter enforcement and better voyage planning to avoid high-risk areas during peak larval release times. To conclude, protecting our ocean requires a coordinated effort across three pillars. First, the scientists must continue developing the monitoring tech and evidence base. The governments must provide the funding, regulation, and port oversight. Lastly, the shipping industry must invest in cleaner technology and commit to reporting and compliance. By understanding the tiny drifting larvae at the start of this chain, we can better manage the massive global shipping frontier that connects our world. Thank you for hearing. Bye bye.